Hey guys, this is Mrs. Chabot. So you've seen in section 4.3, you spend a lot of time looking at where a function is positive and where it's negative, right? Like for its derivative and second derivative more so. All right, so the first step you've already been doing is finding the zeros of the function. But I know the textbook and my math lab likes to plug in a point in between each of those zeros, but you can save a lot of time using this method that I like to teach in pre-calculus, which is using the right-hand end behavior and the multiplicities of the zeros. So this is great for looking at a sign analysis for polynomials and rational functions. So here's a quick polynomial example, right? So I'm looking at some function. I want to know where it's positive and where it's negative. So I factored by grouping and factored completely to find that this one has 3 zeros. Okay, so 3, -2, and 2. So I would mark each of those on the number line like you've been doing. And of course, make sure to mark appropriately from left to right. So f equals 0 at each of those places. Notice I like to label the number line because in most of the problems you'll be doing, you would be looking at a sign analysis for f prime as well as a sign analysis for f double prime. So that way you can keep track of what you're looking at. And when you're graphing, it's also helpful to look at a sign analysis for f. So that way you can see where your graph would be above the x-axis and where it would be below the x-axis. Okay, so the right-hand end behavior here, think back to pre-calculus. You know if the leading coefficient's positive, that means your polynomial would continue towards positive infinity as x goes towards infinity. So the right-hand end behavior here is positive. Okay, so that's whenever the leading coefficient is positive. Okay, now for each of these zeros, the factors only show up once. So again, remember from pre-calculus, we would say that the multiplicity for each of those is 1. And again, from pre-calculus, when you have a 0 with a multiplicity of 1, that means when you're graphing, you would cross through the x-axis. So that means we change signs there. So most of the time at each 0, we'll be changing sign. Okay, so if the multiplicity is 1 or any odd multiplicity, you would change signs at that 0. So it's now quick for me to see that f is positive every place that I have a plus, right? -2 to 2 and 3 to infinity. And again, it's also quick to see that f is negative every place that I put a minus sign. So in this case, it would be -infinity to -2 and 2 to 3. So that's all there is to it. So it's pretty quick to do a sign analysis for a polynomial rather than having to plug something in from something less than -2, something between -2 and 2, between 2 and 3. You'd have to work with a fraction, which is a little annoying. So this is much more efficient. Okay, so now a quick example of a rational function, and let's see an example of an even multiplicity. So how about x minus 3 over x squared? Well, again, I need the zeros, but I also need the zeros of the denominator where f is undefined when I'm looking at rational functions. So the 0 here is where x minus 3 equals 0. So that's just 3. And I'll notice right now the multiplicity is 1, like most of the time. But now I also need zeros of the denominator, which in this case is 0, but notice that factor is squared, right? X squared. So there, the multiplicity is 2, okay? So whenever you have an even multiplicity, like we see here, multiplicity, that means the sign stays the same. So with a polynomial, that's where you would just touch the x-axis. In this case, for a 0 of the denominator, it just means that the sign does stay the same. Okay, and if you plug in some values, it makes sense. All right, so let's take a look at my sign analysis here. So I need to consider zeros of the denominator where f is undefined, and zeros of the numerator where f is 0. Those are all the places where a rational function could change sign. Okay. All right, now what about the right-hand end behavior here? Well, I have a positive leading coefficient over a positive leading coefficient, so my right-hand end behavior is positive. Now 3 has an odd multiplicity, so I'm going to change signs as I cross over 3. 0 has an even multiplicity, so as I cross over 0, the function actually stays the same sign. Okay, odd multiplicity, the sign changes there. Even multiplicity, as you cross over that 0, or 0 of the denominator, the function keeps the same sign. So here we see f is positive, any place I have a plus, 3 to infinity, and f is negative, every place I wrote a minus, so that would be negative infinity to 0, as well as 0 to 3. Okay. All right, and then I'm going to do one more quick example relating back to the quiz from this week. So in the quiz, you were given a polynomial, so that means that your derivative is also a polynomial. All right, so this is what you were given. You found f prime, and then you factored. You all did beautifully. So then it was negative 6x times x minus 2. You all found the zeros of f prime. Again, notice I'm labeling my number line. Were 0 and 2. But to make this quick, let's use this multiplicity method. But what's the right-hand end behavior here? Well, my leading coefficient, my largest degree term, the coefficient is negative 6. So that means my right-hand end behavior is negative. The multiplicity of this factor is just 1, so I'm going to change sign. The multiplicity of this factor for 0 is also 1, so I'm going to change sign. So I can quickly see f prime is positive from 0 to 2, which tells us our original function f is increasing on the interval 0 to 2. And I can see f prime is negative on those other intervals. So that tells me the original function f is decreasing on negative infinity to 0, as well as to infinity. All right, so this method can save you a lot of time. If you have any questions about it, please feel free to reach out to me. And if you feel like it's not working for you, you can continue to pick values to examine on those intervals in question. All right, take care. Have a good day.